All right, so these are the notes on factoring higher degree polynomials. When we are factoring higher degree polynomials, the first thing that you're going to need to think about is, number one, whoops, don't do that. Don't think about whoops, okay? But what we are going to think about is changing the color, toning that down a little bit. All right, so the first thing that you're going to think about is the greatest common factor. That's always going to allow you to simplify the polynomial before you start factoring anything. And plus, if it's completing the square or the sum or difference of cubes, you really can't do anything until that GCF is gone anyway. So always, if it's there, factor it out. Okay, second thing is factor the according number of terms. So if it has two terms, you're going to look at these three things. See if it's a difference of two squares, difference of two cubes, or a sum of two cubes. Now when we're talking about two terms, I'm really talking about when you end up with like x squared minus 4. Well, that's to the second power. So you're going to be looking at two squares. And the difference just means that you have a subtraction sign between the two terms. Okay, so that's when you're going to use the difference of two squares. The difference of two cubes looks like this: x to the third minus, and remember it's difference. I'm going to put stars so that it doesn't get confusing. Minus 8, because 8 is just going to end up being 2 cubed to equal 8. So that would be the difference of two cubes. Now, we can have the same polynomial, but instead of a negative sign in between or a minus sign, we would end up with x cubed plus 8, and that would be the sum of two cubes. All right, now if you had three terms, that would be a perfect square trinomial. And we already know how to factor those out. And then a general trinomial, so you can use the AC method to go ahead and factor that out as well. Nope, go away. All right. Let's see if I can get this to go away. Yay. No. Yay. All right. So the last one is when we have four terms or more, we are going to focus on grouping. Okay? Now, we are not going to focus on factor theorem or rational root theorem. Okay? You're going to learn that next year in pre-cal. I promise. All right? If we were back in the classroom, we would definitely go over those. But those two terms you can look them up on Khan Academy or look them up on your own if you would like to. But we're going to focus on just grouping for this year, and you will see them next year in pre-calculus. All right, so let's go ahead and take a look. Number 3 is we need to see if anything can be factored further. So if we do grouping and then we see, oh wait, we've got a sum of two cubes, we need to keep factoring. All right, so that's what we're going to work on today, and all three of them I'm going to show you we may need to do something a little bit more once we get to that last step after we group. So let's get away. Now, I don't really like the terminology for this, so if you have something better, please make sure you edit it or go ahead and change it. That's fine. Do that. Here are the very basic steps. 1, you're going to take out any common factor of the first two terms. So that's what we're going to do first. So take out any common factor in the first two terms. I'm going to put that in blue. So in the first two terms, notice how I have the variables x cubed and x squared. I know I can take at least x squared out of those first two terms. So when I do that, what's left over is going to just end up being x cubed divided by x squared, which is just going to give us x minus 3, because x squared divided by x squared is just itself. All right. Okay, then the last two terms, I'm going to put that in orange to keep things a little separated. Okay. So the last two terms, we're going to see what we can factor out. Now, I noticed that this negative on the inside, I want a negative over here. So there's a negative in front and a positive. If I factor out a negative number, positive divided by a negative would give me that negative on the inside, and that's what I'm looking for. All right, now 48, I already know 48 is divisible by 16, but I just want to show you. So 48 divided by 16, that gives me 3. So that is divisible. So we're going to go ahead and take a look. This is going to end up being 16 on the outside negative 16x divided by negative 16 is just going to give me x. Positive 48 divided by negative 16, that's just going to give me a negative 3. All right, now the next part, it says take out the common factor in your new terms. So with our new terms, and I'm going to go ahead and change to purple, okay, notice how we have a common factor. Our common factor between both those terms is x minus 3. All right, so I'm going to go ahead and move that to the front. Okay, and then keep factoring if necessary. When I take out that common factor, what's left is just x squared minus 16. All right, now keep factoring if necessary. This one is necessary because, take a look, we end up with, first of all, x minus 3. You can't do anything to that. There's nothing to factor out. That is completely factored. But when I look at x squared minus 16, I can go ahead and continue because I have a difference of squares. So going up here, I have two terms, and I have a difference of 2 squares because 4 times 4 gives me 16. So if I were to rewrite this, this would be x squared minus 4 squared. Okay, bring down the x minus 3. There's nothing we need to do to that. This would just end up being, it's a difference of 2 squared, so one of them's positive and one of them is negative. All right, and that's as far as we can go. Now next week we're going to set each of these equal to 0, and it's going to tell us on the graph where it crosses the x-axis. But that's a little preview of next week. So let's go ahead and take a look at this next problem. Okay, so we are factoring by grouping, so we're going to go ahead and take a look at what can we factor from these first two terms first. Okay, and noticing you cover up the other side. You don't even need to look at it. But out of these first two terms, I notice that I can take out an x to the third from both of them. So this is going to end up just being 2x plus 1. And then on this side, I notice that they're both negative, so I know I'm going to end up dividing out at least a negative number. And 54 divided by 27 is just going to end up giving me 2. So let's go ahead and divide out a 27 from both of them. And that's going to end up giving me 2x minus 1, because negative 27, oh, not minus, negative 27 divided by negative 27 is going to give me that positive 1 over there. All right, now looking at these binomials, if they are not the same, you need to take a step back, and see if something else needs to be either factored out or see if you went a little too far or you have a math error, because 9 times out of 10 you might have one of those if it's a 4-term polynomial. Alright, so at this point I do have 2 terms that are the same, so that would just end up giving 2x plus 1, and then whatever is left over, which in this case is going to be x to the third minus 27. Alright, now I need to ask myself, is there anything out of this first binomial that I can factor out? Nope, it's simplified. This second binomial though, I noticed that this 27 is a cube, so I can actually continue on and write it in that formula, a minus b, not equals, sorry, a minus b times a squared plus ab plus b squared, close parentheses. Alright, so at this point I need to identify what a is and identify what b is. I'm going to bring down this formula, or this binomial, because there's nothing I can do or simplify with that. I'm going to simplify this further by saying x cubed minus 3 cubed. Okay, so there I identify what a and b are. Close parentheses, it just didn't look right. Alright, next thing I'm going to do is I'm going to go ahead and rewrite it. I'm going to write it over here. So I'm going to end up with a is x minus b, which is 3, a squared, which is x squared plus 3x plus 9. Alright, so that's my term, okay? And so I really just need to write this all over again with 2x plus 1 in front, and nothing else needs to be simplified. Now some of you guys might be asking, hey Miss Doherty, or hey, Can I factor this further? This part right here? Well, you could if it worked, but because it's a difference of squares, or a difference of cubes, it will never factor out any further. So this is as far as it's going to go. Otherwise, you'd be taking a look at a times c, which is going to be 1 times 9, and then what factors of 9 that'll add up to give you 3. In this case, it's not going to factor any further, and this is as far as you can go. Alright? Okay, our last problem. Okay, so I apologize, it's split on the page, but I think I can write. Nope, I can't. So it's going to come on down to the next page. And that's okay. So we're going to go ahead and split the middle. First thing that we're going to do is we're going to see what factors of the first two terms we can divide out, and that would be n to the third. What would be left would be n plus 5. Okay, and then out of these two terms we would divide out a negative 8. So what would be left is n, and then 40 divided by 8 is just going to give us a positive 5. And notice that these two terms are the same, so that would be n plus 5 in the first parentheses, and then n cubed minus 8. I can't stop there because I have a difference of cubes here, so I'm going to go ahead and move one more step further. This would be n cubed minus 2 cubed. If I were to rewrite that, hey, it doesn't like that gray line. So n plus 5. Alright, so if we're using the difference of cubes, that's just going to end up being a minus b times a squared plus ab plus b squared. Alright, so I already know that a is n and b is 2. A and b. Alright, so I'm going to substitute those in, so we would end up with n squared plus 2n plus 2 squared, which is 4. And don't forget your original binomial that you have already, which is n plus 5. Okay, there you go. And you would see if you can see any factors of 4 that add up to give you 2, and there are none, so you are done. Okay, that is it for higher degree polynomial factoring. You will see a little bit more next year, and I'm not too worried that this is where we're stopping at this point. Okay, next week we're going to talk about solving polynomials, and then that's it for this unit. Then we're going to go ahead and take a look, kind of a brief look at rational equations. And if you have any questions, please reach out to me in email. I can always set up a tutoring time if you would like to work alone with me. That's fine too. Try to do it before Thursday though. Alright, hope you guys are doing great. Bye.